Hello and welcome. This is Bijan Hushiar. After creating the topology that you see on the screen in Packet Tracer, our plan is to create two VLANs on switch 1 and switch 2. They are VLAN 10 and VLAN 20. We are going to place FA0/10 of switch 1 and switch 2 in VLAN 10 and FA0/20 of switch 2 and switch 1 in VLAN 20. We know that each VLAN is a unique broadcast domain. It requires its own network address. That's why the network address for PC1-10 and PC2-10 different from the network address of PC2-20 and PC1-20. Let's go ahead and create VLANs on switch 1. We access command line interface of the switch and we go to global configuration mode and we start creating VLANs. VLAN 10. That's it. VLAN 10 is created. I can name it with the command name IT. This VLAN is for IT. Exit. Now I'm going to create VLAN 20. VLAN 20. I'm going to name it HR. Name HR. This is for HR people. Exit. The two VLAN created on switch 1. Now I'm going to place ports FA0/10 and FA0/20 in VLAN 10 and VLAN 20 respectively. I'm going to access the interface FA0/10. I'm going to change mode of this port to access. I'm going to allow it or place it in VLAN 10. That's it. I'm going to do the same thing for FA0/20 by placing it in VLAN 20. So I'm going to access it, interface FA0/20, switch port mode access, switch port access VLAN 20, and now perform show VLAN. You'll notice that the two VLAN that we created are going to be displayed. It shows that FA0/10 is in VLAN 10 and FA0/20 is in VLAN 20. If I go to switch 2 and access command line interface and go to privilege mode and perform show VLAN, you'll notice that there are no VLANs except VLAN 1, which is the default VLAN for Ethernet, and all the ports of the switch are placed in that VLAN by default. The name of this VLAN is default and we cannot delete it. We can move ports from it to another one. It is the management VLAN and it is the native VLAN as well. Now we can go ahead and start creating VLANs in here and place ports in the VLANs that we create in here as well. So I have to go to global configuration mode, conf-t. I can start creating the VLANs in here and placing the ports in that VLAN. Now I'm going to do a different thing. I'm going to use VLAN trunking protocol to force all the VLANs that I have created on switch 1 to be automatically copied to switch 2. So I'm going to first perform a command for you, a show command, show BTP status. As you notice, this switch is server. It is not part of any domain. And another important part is that configuration revision number is 0. It's in server mode. I want to change it to client. If I change it to client and change switch 1 to server, whatever VLAN that I create on switch 1 will be automatically copied to this one. But the requirement is that this link must be a trunk, and some configuration must be done first on switch 1. So I go to switch 1, perform show BTP status. It is not part of any VLAN. The switch is in server mode, and configuration revision is 4. The higher the number, the revision number, if the switch is server, that server is going to pass all its configuration to other switches in the switch network. That's why we should not just add a use switch to our network before making sure it is not in server mode, or before deleting its VLAN.dat. Let me show you another command. Perform another show command. Show flash colon. I'm doing this on switch 1 that I have already created a couple of VLANs. You notice that there is a file called VLAN.dat. Let's perform the same command on switch 2 that I have not configured any VLAN. Show flash colon enter. There is no VLAN.dat file in here because there is no database for VLAN. We haven't created any VLANs on switch 2. Let's go ahead and perform some BTP configuration on switch 1 by going to global configuration mode, BTP mode, server. This switch is server, and that command is not really necessary, but to make sure, I just to show you the command how to change the mode of a server to server, a switch to a server. I just performed that command for. And then I'm going to create a domain, BTP domain. I'm going to call it ABC. ABC. A domain called ABC is created, and I'm going to perform the show VTP status. VTP status. And notice that the VTP domain is called ABC now. The switch was server, still is server. Configuration revision went back to 0 because we just created that domain, okay? Which is the lowest one. If it is higher than any other server, it will push its configuration to that switch. If there are client switches, they will receive the configuration, VLAN configuration from the server anyways. Let's go to configuration, global configuration mode, and then access interface FA 0, 1, and let's go ahead and make it a trunk mode. Switch port mode trunk. Why do we need to do that? We need to do that in order to allow traffic for more than one VLAN to pass over that link. We can limit the number of the VLANs that can send their traffic on that one with this command, or allow certain VLANs traffic to be passed over trunk with this command. Switch port. Did I spell that correctly? Switch port. Trunk. Allow. VLAN. The VLANs that we have are VLAN 1, VLAN 10, and VLAN 20. VLAN 1 is the native VLAN. It is default VLAN. It is management VLAN. We have to have a native VLAN on a trunk, because on the trunk, traffic related to different VLANs would be tagged with their VLAN ID. For some backward compatibility with older operating system iOSs that do not tag VLAN ID for the traffic that they send over the trunk, we need to have a native VLAN. By default, VLAN 1 is native VLAN. But in case if you wanted to make another VLAN, the native VLAN, you could with the command switchboard trunk native and then VLAN followed by VLAN ID of that VLAN. It is a good idea to create another VLAN such as VLAN 99, VLAN 23, and make those, make that the native VLAN. I'm going to show it for VLAN 1. I don't need to type this command because VLAN 1 is already by default a native VLAN, but just for you to see the command native VLAN 1. It's already native VLAN. If you had another VLAN, you would have put the ID of that VLAN in here. Switchboard trunk native VLAN followed by VLAN. The same configuration must be performed on the other end of the trunk link, otherwise we are going to have mismatch. So the first thing that we do, we go to the switch to access global configuration mode, access interface FA01, switch port mode trunk. We'll make it a trunk. It's already trunk, is already established. And then we are going to allow traffic related to VLAN 1, VLAN 10, and VLAN 20 pass over this trunk. Switch port trunk allow VLAN 1, 10, 20, no space. If we had another VLAN except VLAN 1 as native VLAN, we should perform the switch port trunk native VLAN followed by VLAN ID of that VLAN. I'm going to just do it for VLAN 1. We don't have to because by default it is native VLAN. But for you to see the command, I perform it. Another thing that I do is I change the mode of this switch to client for VTP domain ABC. So I have to do that configuration here. So I go and perform. First, let me do the show VTP status you'll notice that it is server, not part of any VLAN. I'm going to change that to client and part of ABC BTP domain. So I go to global configuration conft and perform BTP mode client. That's it. And I change that. I create a domain. Right now, BTP domain ABC. Okay. I haven't configured or created any VLAN on this switch yet. I have created VLANs on that one. But let's see if BTP has pushed uh, uh, the configuration we made on switch one to this one. Let's go to privilege mode and perform show VLAN. There you go. These are the ones that I created on switch one. But switch two shows that they are already created. Why? Because it is a client, BTP client, and server one is a BTP server. Whatever VLAN we create on S1 will be pushed to S2 or any other client switch or any other server switch with lower revision number than S1. Never add a switch that is a use switch with configuration on it to an existing network without deleting VLAN.dat. In order to delete that VLAN.dat, you have to go to privilege mode and you perform delete flash colon VLAN.dat. I don't want to delete this one because I'm going to continue with the configuration, but this is the command that you definitely perform on a used switch that you want to connect to your switch network. Otherwise, this used switch that you are adding may have a higher revision number, BTP revision number, and changes the VLAN configuration that you have on your entire network. So be careful about that. I have to place ports in these VLANs. It's true that VTP pushed whatever VLAN that we had created on S1 to S2, but I didn't do anything about the ports. The ports must be done locally on that switch. So I go to global configuration mode, access interface FA 0/10, and place it in access mode, change it to access mode and place it in VLAN 10. Switch mode, access, switch port, access VLAN 10. Go back to global configuration mode and perform the same thing for interface FA020, switch port mode, access, switch port, access VLAN 20. If I perform show VLAN now, show VLAN, you'll notice that FA010 was moved from VLAN 1 and placed in VLAN 10, that is named IT. FA020 was moved from VLAN 1 and placed in VLAN 20, which we named HR. Now, the other thing is that to configure the PCs, all the PCs in VLAN 10 must have the same network ID. All the PCs in VLAN 20 must have the same network ID, different from VLAN 10's network ID. PC 1-10, I'm going to assign 192.168.10.1 PC2-10, I'm going to assign 192.168.10.2. PC1-20, I'm going to assign 192.168.21, and PC2-20, I'm going to assign 192.168.20-2. There you go. Let me double check to see I didn't make any mistake on assigning the IPv4 addresses. They look good. Now it's end-to-end connectivity. PCs in VLAN 10, shown with this color, can ping each other. PCs in VLAN 20, I'm showing with that color, can ping each other, but PCs in VLAN 20 cannot ping PCs in VLAN 10. Let's just go ahead and from PC1 ping 192.168.10.2, which is the IP address we assigned to PC 2-10. The communication occurs. Let's see if it can ping any PC in VLAN 20. Shouldn't be able to do that because those are two separate VLANs. They cannot communicate with each other. In order to be able to have PCs in different VLANs to communicate with each other, you've got to have inter-VLAN routing configured. So PC1-10 can ping PC2-10, but it cannot ping any PC in VLAN 20. Let's go to PC1-20 and ping another PC in VLAN 20.2. Communication is there. Let's see if it can ping any PC in VLAN 10. It shouldn't be able. We are not going to receive any replies back, which is okay. PCs in different VLANs cannot communicate unless we configure inter-VLAN routing. Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.